Welcome to IT Pro TV. I'm your host, Don.
Coming at you live from San Francisco, California.
You're watching IT Pro TV.
Hello, and thank you for watching IT Pro TV, helping you level up with IT learning everywhere you go. I'm your host, Zach Memis, for this episode of CompTIA Linux Plus. What we're going to do now is back up and restore data. You want to join us? I think you do. And Don Bezet is here to show us the way. Don, good to see you, sir.
Hey, glad to be here. And, we've been talking about Linux security the last few episodes. Most of it's been preventative measures. We've been trying to stop people from messing with our systems.
Yes.
In this episode, we're going to go a little bit different. And we're going to say, all right, let's say something bad does happen to our system. Maybe we have a disk failure, maybe a hacker gets in or whatever. And we need to be able to restore and get our system put back to the way it was. So we're going to take a look at some of the different ways that we can back up our data inside of a Linux system. And we'll talk a little bit about how to restore it, because otherwise the backup's kind of pointless. So that's really what's all coming up right here in this episode.
So Don, how do we decide what kind of backups we need?
So there are a number of different types of backups that are out there. And it also varies based on the type of system that we're on, right? For home users, the way they're going to back up their system is very different than the way you're going to back up a server, right? So understanding the data that you're working with is kind of the first stage. And more importantly, understanding the size of the data, because some backup types are just not realistic if you have a massive data set, and some backup types are just far too complex if you have a very small set of data. So we need to understand a couple of things about our own data first. And the main thing we need to know is how sensitive is our data, right? The question I always ask is, how much data can you afford to lose? If your computer crashed today and you lost all the data that was on there, and then I said, hey, I've got a backup that's 7 days old, can you afford to lose 7 days worth of data? Well, if it was my computer at home, I'd be fine. I'd be fine losing a couple of months of data on my computer at home. It's not a big deal, right? But on my work computer, that would be a problem. I've got a lot of information I would have to rebuild. It would be a pain, but it wouldn't be a nightmare for me. It would just be a pain. But maybe you're a hospital, right? Or a government agency where losing even a day's worth of data can be significant. Amazon.com, they generate over $1 million in sales per hour. So imagine they lost an hour of sales. That is a significant monetary penalty. So we need to think about how much data we need to recover and how quickly we need to recover it. Now, if you can't even afford to lose a minute of data, you're going to be constantly running backups so that you've got the latest information possible to be able to restore that back. But the bigger your data set is, the far less realistic it is to do big backups. So what I'm describing to you right now is what's called a full backup. Let me bring up this diagram here. With a full backup, you establish an interval. So maybe yours is 24 hours, and you say, look, I need a backup, and I can afford to lose 24 hours of data. So you start running backups once a day. And that backup is a full backup, all of your data. So all of your data gets backed up on Monday. Well, then Tuesday rolls around and you back up all your data on Tuesday. And then on Wednesday, same thing. Thursday, same thing. And notice how it gets a little bigger each time. It's a little bigger because we're adding more information as we continue to work with our computer or our server or whatever it is. New data is being added all the time. So that it gets bigger and bigger and bigger. Now, if that full backup takes an hour, then it's not a big deal, right? You run it once a day, maybe you schedule it in the middle of the night, you don't even know what's happening, right? This is how I back up my computer at home. But over time, it's going to get bigger. And the bigger it gets, the longer it takes to back up. Maybe that 1 hour backup becomes a 2 hour backup after a few months, and then a 3 hour backup by the time you hit the next year, and then a 6 hour backup by the time you hit 2 years from now. When it's a 6 hour backup, maybe it's big enough now that it can't run overnight anymore, that it starts running into the time when your users are in the system, which slows down their access and creates a bad user experience, right? Maybe the backup gets so big, so much data, that you can't even do the backup in 24 hours. Now what do? Now you can't do a backup every 24 hours because it takes longer than 24 hours to do the backup. Now we're talking about a big data set at this point, right? Way before you hit that point, we could have broken this backup up. You can divide it into what are called differential or incremental backups, right? These are where we do different types of backups. You do a full backup on that first day, right? So you do a large backup of all of your data as it is at that point. But then the next day, you change things up. Instead of running the full backup again, you say, look, that full backup hasn't really changed. I'm going to keep it, and let's just back up what's new, what's changed, right? And with a differential, each day it uses that full backup as a baseline. and then it just backs up what changed since that first day. Now, that's going to get bigger and bigger and bigger each day.
Mm-hmm.
It's getting bigger because of all the changes that have occurred since that full backup was done. But ideally, especially if your changes are a minimum, then it's going to be a much smaller backup each night, which allows you to get it done in a reasonable amount of time. Okay. Now, on a positive side, that makes your backups more efficient. On a negative side, if you have to do a restore, if something goes wrong and I've got to go get my data back, I have to restore the full backup and I have to restore the newest differential backup that I have. This Thursday backup has the changes from Wednesday and Tuesday in it because it's everything that's changed since the last full backup. But I have to have 2 backups in order to restore and get back to current. Otherwise, I'll be all the way back here on Monday if I just have the full. Or if I just have the differential without the full, it's going to be missing a lot of data. You have to have those 2 pieces. Okay, so a little bit more complex in exchange for being a lot more efficient. Right now, with massive data sets, even this is not realistic because that data is getting bigger and bigger. I mean, look at Thursday here. That red bar is actually bigger than the full backup was back on Monday, right? They must have added in a bunch of new data or something. So that's not really helping us all that much. So another system we can use is what's called an incremental, all right? And if you take a look at an incremental, it's different because it doesn't, well, it starts off the same as a differential. You do a full, right? So we've got this full backup right here. And then on Tuesday, we just back up what's changed since the last full backup. But where it gets different is over here on Wednesday. On Wednesday, it just backs up what changed since the last incremental, since Tuesday. And then on Thursday, it just backs up what changed since Wednesday. Very, very small, smaller data sets. This allows our backups to happen much, much faster, right? They take less time. They're far more efficient. The trade-off, though, is complexity. If I have a failure on Thursday or on Friday, and I want to go and do a restore, I've got to restore the full backup, then Tuesday's backup, then Wednesday's backup, then Thursday's backup, restoring each one. And when I get them all restored, now I'm all caught up, right? What if I'm missing my Tuesday backup? I could restore Monday and Wednesday and Thursday, but I don't have Tuesday. So if something was changed on Tuesday and then not touched again the rest of the week, then I've lost that work, right? So I have to have all of these backups to get restored. That's far more complex, right? But it's way more efficient. And you'll see places where they have like sensitive databases where they'll do a full backup at midnight and then they'll do incremental backups once an hour, 24 of them all throughout the day, right? Or incremental backups every 15 minutes or whatever to get the backup window nice and small so that you lose the least amount of data. That's what we need to be thinking about when we set up a backup for a system. If it's a workstation, if it's a server, we need to think about our backup window. How much time do we have? If we have a failure, how much data can we afford to lose? And that's going to point us in the direction of which of these technologies we can use. If our data set is small and we can afford to lose a bit of data, just running full backups every day, that works out great, right? But if it's a big set of data and we can't afford to lose, then we've really got to be efficient, and that's when we end up with incremental. So these are all the choices that we make before we dive in and actually set up a backup.
So my question now is, how are these backups stored?
You know, they can be stored a number of different ways. The old kind of standard for this stuff was to use tapes, right? The LTO tapes or DLTs, they're these big server type cassettes that you would pop into special tape drives, and they could hold, well, they used to hold gigabytes. Now they hold terabytes of data, and you can back up to them. They're slow. They write in serial order, bit after bit after bit. So they're not very efficient, but they're cheap for large amounts of storage. And so data centers around the world have used them. But in today's world, tapes are pretty uncommon. Most of us do not have a cassette tape loader on our
or like
PC.
a reel-to-reel, big reels.
Yeah, that's even older, right?
Yeah,
the
yeah.
cassettes are usually just a plastic square. So, I mean, there's a lot of options there. But that's kind of the old way. So now, I mean, you can back up to DVD and CD as well, but those, we've kind of exceeded their space. They're just not big enough. So today, most backups are actually done digitally. So you'll back up to a removable hard drive or a storage area network or a remote server somewhere else completely outside of your network, right? That's the whole premise behind cloud storage. Things like Google Drive and Microsoft OneDrive or Amazon's S3 and Glacier and all these other technologies is get the backup out of your building. And that way, if your building catches on fire, your backups are out somewhere else,
Yes.
right? And the cassette tapes let us do that too, is you could back up to a LTO tape, stick it in a box and ship it off somewhere, and now it was off site. So you had that protection. When you're backing up to hard drives, doing it digitally, there's that risk. I know a ton of people who run Macs and they use Time Machine. And Time Machine's great. You stick a little USB hard drive on the back of your Mac and it backs up automatically. You don't have to worry about it. And then when your house catches on fire and burns down, your Time Machine drive burns down with it, right? Because it's right there. You've got to send things off-site. So that's an important piece of any kind of backup that we do. So regardless of which destination you pick, it needs to be something you can send out outside. Now, when you take a backup, we might be backing up just individual files, in which case we're copying the files right over the disk, or we might be doing image-based backups, right? There's images, clones, those kind of things. When we do those, an image is where, or actually images and clones are kind of the same thing. We take a disk and we take a complete duplication of that disk, bit for bit, across the platter. That's really cool because it's not just files anymore. Now it's the whole system. I could restore the entire system with that backup. Really neat stuff, right? If it's a virtual machine, we can do snapshots. Virtual machines let you just do a quick snapshot of that virtual disk to catch the changes, and you can do incrementals and things that way, which is another pretty cool technology. These are all different ways that we can do backups, but at the end of the day, it's still data that has to be stored somewhere. It can be stored on disk, but we just need to make sure we have some kind of way to get it offsite.
What is a quick and easy way to back up files?
All right, so we can go with the old trusty, right? Remember, I mentioned that tape is kind of where we started on a lot of this stuff. So one of the de facto tools found in every Linux distro is a utility called tar. tar stands for Tape Archive. And I can't remember the last time I encountered a distro that didn't have tar installed by default. So you probably have it here. I'll pull up. I'm on a CentOS box. I'm just going to run man tar. And there it is. Here's the Tape Archive utility. It's a standard GNU utility, so that's why it's packaged with so many different things. And what tar lets you do is, originally, it lets you take a bunch of individual files and glue them together into one big file so they can be written to a tape, right? That was what the design was. Well, we can still use it today to take a whole bunch of files and glue them together into one file so that we can store it as a backup. So if I need to back up like my home directory, I want to have a good backup of my home directory. I can do that just by using tar. And the utility itself is pretty straightforward. There's a few command line tags we need to be familiar with it. I'm going to back up my home directory. So I'm just going to say tar. And then the two main options to remember are C and X. C lets you compress things or add things to an archive. X lets you extract things. So when I'm backing up, I'm going to use the C option. When I'm restoring, I'm going to use the X option. All right. The other options I'm going to use are the same between them. I'm going to use V, which makes it a little bit more verbose. I'll get some screen output as it runs through. It'll list the files. I don't want it to just run silently in the background. I'll do Z, which tells it, don't just glue the files together, also run it through gzip and compress it, make it smaller, right? You can actually try and store your backups compressed. That'll save some space and you can potentially back up more data. And then lastly, F, which tells it I'm going to give it a file name for my backup, right? I want to call mine backup.tgz. Okay, now I don't want to just stick it here in my home directory though, so I'm going to put that into a mount that I have. So this is a extra hard drive I have in my system. So I'm going to back up to that location, right? And then I need to tell it where to find what I want to back up. And I'm going to back up /home/dpossett, my home directory. Or I could point to just my documents folder or whatever. But we do need to have permissions to access whatever we're backing up. You can't just go and back up anything. And so when I run this command right here, it's going to take my home directory, and I'm getting a nice, good visual output here, right? So I can see what it's grabbing, and it's going to back up all of that. And now I kind of regret it. Looking at it there, it just backed up my Firefox cache folder, which can be really big, and you don't care about the cache. It's kind of a waste of space. So I probably could have been a little more specific in my backup and told it exactly what I wanted. But in this case, it backed it up fast enough. I can see that it grabbed every file out of my home directory. I didn't see any errors as we passed. I could scroll back and look. Usually you'll see maybe a permission denied or something will pop up. But everything there looks good. And if I take a look at /mnt/storage1, where I parked that, I can see that I have a file called backup.tgz, which is what I chose to name it. TGZ, when you use tar, you'll usually add a .tar file extension. GZ is what we add for a gzipped file. So TGZ means it's tarred and gzip, or some people actually do tar.gz. So it's up to you how you want to name it. The extension actually doesn't matter, right? It's just a way for us as humans to remember what it is. And I'm going to do a ls-lh on that just so we can look and see that my backup was 109 megabytes Okay, so it backed it up and it stored it right there. And now each day, if I run that same command, it'll back up my home directory and park it on this other disk. If my main disk fails, I've got a backup of my home directory right there. And I can go and I can get it. And I can put this in cron and tell cron, hey, run this once a day. Run this once an hour or whatever. It'll run in the background. I won't even realize it, right? And that's how we can start to set up a backup strategy. But this would be considered a full backup because it's not looking to see, did something change? Did something stay the same? It's just backing everything up and throwing it right there in that file.
So, Don, now that we've backed it up, how do we restore it?
All right, it's basically the same command. We just change it a little bit, right?
Okay.
That C becomes an X, right? So I'm just going to come in here and actually, I'm going to make a subdirectory. I don't want to restore right back into my home folder, so I'm going to make a folder called restore. And let me just get into that. And I'm going to restore it into here, right? So maybe I can pick and choose the files that I want. And I'm going to run tar. Now, last time I ran CVZF, right? I'm going to change that C to an X. I want to extract. I want it to give me verbose output so I can see it on the screen. I want it to process through gzip because it's going to have to uncompress this. And F, I'm going to tell it a file name. And so then I'll point it at that backup file. So I'm just going to point it at /mnt/storage1/backup.tgz. And then it's going to restore right into the folder that I'm in right now. So I'm in /home/dpossess/restore. So when I run that, there it goes extracting all those files and kind of putting them back. It runs pretty quick.
Yeah.
And if I take a look in there, I'll see a home folder. Tar backs up with the full path. And so I backed up /home/dpossess. So here's /home, but I only see my directory inside of it because that's all I had permissions to. And then dpossess, and inside of there, there's all my files. All of my other things, even the hidden files were backed up. They're all there, and I can go in and get at my information. So I haven't lost anything as long as I have access to this backup file, which I put on another disk. And so it's sitting right here. If something happens to this disk, I lose my backup, right? So it shouldn't be the same disk as the data you're backing up. Even if it's separate partition, that doesn't count. It needs to be at least separate physical hardware, another physical disk, or even better, stored somewhere else. And I could take this and send it up into Google Drive or a SFTP server or something, and now I've got an offsite backup of my home directory.
So, Don, can we tell Tar to only back up files that have changed?
You know, there's one thing that it can't do, right? So it's an older utility. It's not that fancy. It just backs up what you tell it to back up, and that's it. It doesn't look at change status or anything else like that. So if we want to go a little more advanced, there's a new utility we can use called DAR. DAR is the disk archive as opposed to tape archive. It is not installed by default on most distros, but it's usually available in a repository. You can install it real quick and make use of it. So let me show you here. I'm going to switch over to an Ubuntu machine. And on this one, I'm just going to run DAR. And all right, command not found. So let me install that real quick. And it's a really small utility. It's less than 4 megabytes there. So it's going to get installed. And once I've got it, DAR operates a lot like tar, except when you run it, you can tell it just to back up the things that change. You can do differential or incremental backups. It actually supports both. So the way that works is by, well, first, we start with a full backup, right? Now, the syntax for DAR is a little easier than tar. Tar actually follows a lot of BSD syntax. So with DAR, I'm just going to say DAR -R. So I'm telling it I'm going to point to a directory, and I want it to be recursive. I want it to back up all the subfolders and stuff. And then I'll point it to a folder. So I'm going to do /home/dpossess, right? So I want to back up my home folder, right? And then I tell it where I'm going to store it, right? So I'll do -C, and I'll specify a file name. So I'm going to point this to /mnt/storage1/ and I'll just call this one full.bak, all right? Now, the file extension doesn't matter. The name doesn't matter. I'm just naming it full.back so I can remember this is the full backup that I did. When you run that, it's going to go through and try and do that backup. Now, I got a warning on mine popped up. There were a couple of things that I didn't have access to. So it looks like the random number file, the vim info file, those aired out. I'm actually okay with those. The .rnd, random stuff anyway. I don't need that. So I'm good there. But everything else looks like it backed up okay. So that is fine. And now I've got my backup of my home directory. And if I do a ls-lh of /mnt/storage1 and take a look in there, I can see that full.back and see how it stuck some more information on the end, .1, .dar, right? So it's kind of keeping track of when this was backed up. And it's 243 megabytes sitting right there. And it ran a lot faster than tar did. The main reason there is not that the utility is actually faster, but that it didn't display all the file names on the screen. That actually slows tar down. But it ran that backup, and now I've got a backup of my home directory. That's a full backup. Okay, so now, I might get into my home directory and start changing some files. I might create some files, add some data, whatever it is that you do as you kind of work about on a system, just whatever it is. Just trying to add a little bit of fake data here. And so now I've got data that's changed. Okay, so with DAR, we can then do a incremental or differential. Now remember, with incremental and differential, their first backups are really identical. You're backing up all the changes since the last full backup. And the way we do that is by saying dar -r and pointing to our directory, right? So that's the same as before. We do -c and we tell it the file that we're going to back up to. So again, that's kind of the same, except I'm going to call this one something different. Instead of calling it full, I'm going to call this one, I can either call it differential or incremental. It'd really be about the same. So I'm going to call this one, I'll just say incr.back. And actually, let me stick a 1 on that. incr1.back. So I'll do an incremental, right? Now, at this point, it doesn't actually know I'm going to do an incremental. If I were to press enter, it's going to just run a full backup. And actually, I need the whole path there to where I want that to go, or it'll end up in my home directory. All right. So the way we tell it that it's actually going to be a differential or a incremental is by referencing the full backup. So I need to add a -a and point to that full backup. So I'm going to point to /mnt/storage1/full.back.1.dar. So I'm pointing to that file. And you can actually leave off the .1.dar and it'll figure it out. But basically, I'm pointing to that file. So once I point to it, it's going to know, okay, wait, that's what I'm based on. And now I'm just going to get anything that's changed since then. And when we run that, it's going to go through and here it's warning me. It's just saying, it looks like there might be, this might be a slice. A slice is where it has to break up a file into more than one piece. Mine's actually not sliced. It's a single file. So we can just say yes to this. And then there it goes. It reads through it. And I still got those same 2 files that I don't have permission to access, right? So we should probably exclude those. But otherwise it runs and it found 1 inode save, just 1, right? And that's because I only changed a single text file, a text file that was so small it fit in 1 inode in the disk. So this is going to be a super small backup. If I take a look at /mnt/storage1, and let me do a -lh on that, I can see that incremental is 396K in size. Very, very small versus the 243 megs that the full backup had. Okay, so now it knows that I've just backed up changes since the full. Okay, now if I'm doing differentials, I'll just keep running that same command over and over again. Differentials are always based on the last full backup. Okay, incrementals though are going to be based on whatever the last backup was, whether it was full or incremental. So if I want to do another incremental, what I would do is, let me just back this up a little bit here. And so I'm going to do a backup. This is, whoops, let me just get rid of my whole command there. So I'm going to do a backup to incremental2.back, right? But this time when I do the -a, instead of pointing to the full, and if we point to /mnt/storage1/incremental1, and I'll just get rid of the .1.dar on the end so it doesn't complain. When I point to that, now it's going to say, I just want to get changes since the last incremental. That's where we start to differ from a differential, no pun intended. So that's where we kind of change. But otherwise, the syntax is the same. And when I run that, it's going to do a backup. I haven't made any changes, so I get 0 inode saved. If I create a file or something, then it's going to have a little bit of activity to do. So this one, if I'm creating incremental 3, I'm going to reference incremental 2 as its source. And so it's getting changes since then. And now I get 1 inode saved as it does that backup. So it's backing up each one. And when we go to restore, well, the restore, we just have to step through them one at a time. So to restore these, let me just make a subfolder here instead of restoring over my actual data. What you'll do is dar-x, so you're extracting the data out of the restores, and then you just point to whatever it is that you're restoring. So if I want that full.back, right? So I'm going to point to that, and it's going to restore the full. Now, if all I want is the full, that's all I've got to do, and I can stop right there, okay? Or if I have differentials or incrementals, I can then proceed to restore those as well. And to do that, you would just say dar-x, you would point it at the file you wanted to restore. So I'll do incr1.back, and then I'm going to specify a -w to let it know that I'm restoring over the top of some other data, and then I'm going to continue on restoring, right? So that one's going to go and restore, and then I would just step through each one. If it was a differential, I would just need the newest differential. But since they're incrementals, I've got to go through and do each one to get all the way back to current. So there's INCR3. And now that's restored, I can come in here and I can look, and there's the test1.txt, the file1.txt, those files that I created. Those were in the incremental, and all of my other data is there from the full. So a very powerful utility and a great drop-in replacement for tar.
But can we back up an entire disk with DAR?
You could. What you're going to run into is file permissions, right? Like I did right there. I'm in my own home directory, and there's files I don't have access to, right? You can sudo the dar command, and there'll be files that you don't have access to. There's a lot of stuff that isn't designed to be backed up like this, right? So if you want to back up an entire disk, dar and tar really aren't suitable for that. Instead, there's another utility, and I'm going to switch back over to my CentOS box. There's another utility called DD, right? DD is
Daredevil.
Oddly enough, so I wondered for years, what does DD stand for? Because I assumed it stood for disk duplicator, right? But it actually stands for copy and convert. Seems odd, doesn't it?
It seems very odd,
So
yeah.
CC was already taken by the GNU-C compiler.
So they just went to the DD.
So they just went to DD.
There you go. Makes sense.
Unix acronyms make no sense. So DD is the copy and convert utility. So you can copy a disk and you can convert it into a different format. You can actually copy one disk to another disk if you want, or you can convert it into an image. So I know we're running low on time, but let me show you an example here because I think we can get through all this. So I have a couple of disks. So here, like I've got my SDB1, that /MNT/storage1 that I keep using, that's actually this /dev/SDB1 disk, right? So if I want to clone that disk, either the whole disk or just the partition, I can use DD, I can grab that partition, and then I can put it somewhere, okay? So if I want to grab it as an image, if I want to grab it as a whole disk, that's up to me, and it's all done using that DD command. Now, you will normally need to sudo the DD command, all right? Because that's what's going to give you full access to the disk so you can read it, but also because you're going to write it somewhere. So let's say that I wanted to clone SDB1 to SDD1, okay? So I just want to make a clone of that disk as it is right now. So I can use DD. You specify an input file. So I'm going to say if equals, and I'm going to point to /dev/SDB1. Okay, I want to grab that partition. And then you specify an output file, OF. And I'm going to point to /dev/SDD1. Okay, now it might be unhappy because my partition sizes are different, or if the partition is in use, like SDD1 might be in use. So in that case, it might get unhappy. In those scenarios, if you clone the entire disk instead, it can work a little better. Let's see how it runs for me. So I'm going to run it. It's a very old command, so you don't get a lot of feedback on screen, but it's going to run through and it's going to clone the disk. Now, I will tell you, DD takes a long time. That's why I'm doing a partition instead of the whole disk. If you do the whole disk, it'll actually go through and read every block of the entire disk, even the empty blocks. So if I have a terabyte disk with only 5 gigs of data on it, it reads a terabyte of data. It takes a long time. But in this case, I have a pretty small disk, just 1 gig. I did that on purpose to make it fast. So it runs and it processed it. And now it's cloned SDB1 into SDD1. So things have changed a little bit. You know, looking up here, I can see where my SDD1, see how it's a terabyte, 1,000 gigs. Let's see if that's changed any. And when I look at it now, it's still showing as that 1,000 gigs, right? Or 1 terabyte. But the data that was on SDB1 should now be in there. So let's see what we can get here. I'm going to create a directory. Make storage 3. And I'm going to mount /dev/SDD1 into /MNT/storage 3. And you know what? I'm going to sudo -s just so I don't have to sudo every command I type from here on out. So let me go into MNT. And if I go into storage 1, right? So this is where I had my backup.tgz that we backed up at the beginning of the episode. If I go into storage 3, this disk was empty earlier. And, I see that it's empty right now. My restore failed. So it didn't actually restore it, probably because the partition was open. DD doesn't give us a lot of feedback on the screen. And so, we don't necessarily see that an error occurred. In my scenario, it actually didn't clone that disk over. So what I need to do is kind of repeat that process and actually get it put in there the right way. Now, things like this actually happen quite a bit. And that's why we don't normally clone disk to disk like I'm doing right here. Instead, we take a kind of a middle stop on the way. Instead of cloning to a disk, we clone to an image file first. And then later, we just restore that image onto another disk. So let me show you that because that can help me get around this error. So I can come in and, I still have to sudo. All right, so I'm going to sudo, and I'm going to do dd. I'll specify an input file of /dev/sdb1, right? So I'm going to grab just that partition. And for my output file, instead of pointing to another disk, I'm going to point to a folder, and I'll just call this, sdb1.img. I'm going to create an image file. By pointing to a file name, DD will know I want to read everything that's on /dev/sdb1 and write it to this image file. And once I've got it written as an image file, I can then go and restore it and put it back in place. If I do that, now I can go and take a look at that folder where I just put that file. And there we go. I've got sdb1.img right there. And look at the size of that file. Let me just change that. It's 954 megabytes. Okay. Now, I know that the SDB1 disk that I have mounted to storage 1, actually, is it unmounted right now? I'm not seeing it in my list. But I know that it's only got, well, here, we can pull up a listing of /mnt/storage1. It's only got a couple of hundred megs of data in there, right? 109 megs of data. But the image file I just made is 945 megs because it backs up the entire disk, even the empty sectors, right? Just like I mentioned. But now I've got this image file, and I can take that image file and I can restore that somewhere else. Now, actually, I know why it didn't work a moment ago. I'm just backing up the partition. And when I restore that, if I'm just restoring the partition without the partition table, it's not going to be very happy about that. So it's going to have a little problem there. I backed up my data, just not the actual partition table. So in my scenario, I would have been better off backing up the entire disk. That gets the partition table as well, and we can clone that over. So kind of going back to my other dd command, way back at the beginning where I went disk to disk, if I just get rid of the ones at the end, if I back up SDB to SDD, that gets the whole disk and the partition tables. Now, unfortunately, my disks are a terabyte in size, so that's going to take a little while if I run that as it chews through it. But at this point, it's able to do that clone. Now, I backed up to an image a moment ago, and if we wanted to restore, all we have to do is do it in the opposite direction, right? So when I do dd/input file, my input file would be that image. So I would point to wherever that image happened to be, file.img or whatever I named it. And then my output file would be a physical disk like /dev/sdd or whatever. So you restore the image to the actual physical disk. DD is really powerful like that. It's great for making bootable USB keys and other things. Quick way that we can clone the entire disk. And now you don't have to worry about all the permission denied type things that pop up with DAR because you're actually getting the whole disk and it makes it easy to restore. So pretty cool utility.
Are there any other backup utilities that we should know about besides all this?
Those are the only ones that I'm going to show here in the episode. But in real life land, there are a couple more you'll want to be familiar with, especially a utility called rsync. rsync is a really neat one that's been around a long time that lets you take a directory of files and synchronize it to another directory of files somewhere else, right? And it can synchronize just stuff that's changed or things that were the modification date or permissions have changed. It can sync that stuff. Really, really cool if you need to keep two directories in sync. And that's what rsync is. It's remote synchronization. It's a cool utility. If you're using the Logical Volume Manager or LVM, there's a mirror VG command where you can mirror a volume group. So kind of like DD was taking a disk image from me a moment ago, mirror VG will basically create a mirror, a duplicate of an entire volume group. So another great one. SCP is the Secure Copy Protocol, and SFTP is Secure File Transfer Protocol.
Right.
Both can give us encrypted tunnels to copy files across the network to make it backups that way as well. So those are all really cool utilities that fit in certain use case scenarios, especially scripting. But otherwise, DAR, TAR, and DD, those three utilities right there are kind of our go-tos for doing backups inside of Linux.
Well said, sir. Backup and restore data. Another wonderful episode inside of CompTIA Linux Plus. And before we move on, Don, did you have anything else you'd like to say?
No, not really. If you're wondering, my DD command is still running in the background. It'll probably take 30, 45 minutes because it's got to churn through that whole terabyte. So always be careful with that. Test your backup strategy. Make sure you've designed it for the window of time you have. And more importantly, test your restores. A lot of people do backups and they never test the restore, so you don't actually know if you can rely on that data or not. Always test that out. Make sure that your backups are successful and keep some kind of log so you can see if backups fail. You always want to know about that before you have a failure, not after. That's terrible.
Awesome advice. Thank you, Don. And here's some more awesome advice. Watch every single episode of CompTIA Linux Plus. You're going to be so glad you did. If you missed some, go back, watch them again, and study them and take notes and keep studying. You know, that exam is inevitable. It's coming, and you're going to be ready for it if you follow these simple rules. And make sure you also take advantage of the supplementary information in our course library. It's there to do only one thing, help you be even more successful, so check that out as well. And tell everybody you know about IT Pro TV. IT Pro TV is binge-worthy. Thanks for watching. I'm Zach Memis.
And I'm Don Pizzette.
We will see you again soon.
Thank you for watching IT Pro TV.